be higher than third degree? Fourth and fifth and sixth. Yeah, see, you're already still getting there. Yeah, it keeps going. So before I forget, there we go. All right. So we did our test, mathematic higher power. So that's the sheet that you have in front of you. I've already created a Frere model for notes. I will have Frere models for the entire unit done probably during my planning today, and give those to you tomorrow so that you start having practice once we finish this task. Brianna did a great job with Hero Friday last week. Anybody want to volunteer for Hero Friday tomorrow? Davian, thank you. All right, so Davian's tomorrow. So, higher power functions. I do want you to notice, looking around the room, when you look at all the white books, what form are these polynomials in? Standard form. Remember, keep the difference between the type of function and the form that it's in. All of these are in standard form. What we're about to learn is how to connect the possible number of intercepts and the extrema and the end behavior to that equation. So we're going to learn about all three of those things. So here's our proficiency scale. Now this is what we are focused on right now. Okay. So notice this is the one that says starting with an equation. So Unit 5 polynomial functions starting with an equation. Some of this review, hopefully we very much know. Zeros, roots, x-intercepts. Hopefully you can go ahead and mark that off because you're pretty comfortable with it. We're going to build more understanding with it. Fundamental theorem of algebra. Hopefully we know that one backwards and forwards because we've now had 2 units where we've used it. Polynomial function, guys looking around the room, y'all stressed me out about polynomial function when I looked at the test. Some of us understood it pretty well, but we need to address it better. Hopefully we're good with degree, domain, and range. Leading coefficient is the one thing we haven't actually talked about yet, so we're going to talk about that, but hopefully we remember it from Algebra 1. Notice this foundational piece is a lot from Units 3 and 4, and we're going to continue working with those ideas. The only thing not from a previous unit is identifying degree and leading coefficient, because we just haven't done leading coefficient yet. Okay. Please notice right here, and I need to make this clear because you got to know what you're getting yourself into. What we are trying to do is not identify what the x-intercepts are based on the equation. I'm trying to determine the what? Possible number of x-intercepts, which hopefully a lot of us are already aware of what the possible number is. We're going to make sure we understand that. Please notice right here, we're going to try to determine the possible number of what? Extrema. Now, what do I mean by extrema? I want to make this clear. What's another term that we have already learned, or actually 2 words, that make us think of extreme values? Maximum and a minimum. In mathematics, when we say extrema, that just means extreme. Now, first off, I will point out it's coming from a Latin root, so this is plural. If you only have one, it's going to be extremum. But we just mean the maximum, well, maxima really, or the minimum, right? So when we're talking about the number of extrema, I'm just talking about the number of max and min. Okay, so keep that in mind if you want to make that note to yourself somewhere soon or whatever. But please notice, am I asking you what the actual extrema are based on the equation? No, because at where you are right now, do you know what you would have to use in order to find what the actual extrema are? Say again? And what part of that calculator? The graphing calculator, right? The graph component. So there's no way for me to expect you to know these things without a graphing calculator, but we actually can know a possible number of x-intercepts, a possible number of extrema based on the equation, and we can definitely always figure out the end behavior just looking at the equation. And so that can give us a lot of information, just kind of visualizing what this function looks like. Last little bit there, we're not going to get to today. I've mentioned this before, so I just want to give a little heads up. Anybody remember what I said a quartic function is? What degree that would be? That's 4th degree, right? Quintic. fifth degree, right? So quartic is my fourth degree, quintic is my fifth degree. And then today we're also going to introduce, or maybe tomorrow, the idea of an absolute maximum and minimum versus the relative, right? So that test, we had relative max and min. Sometimes we have absolute, so we're going to talk about that. A lot of the second one is built on the same things, but you'll notice here, it's understanding a polynomial if I'm starting with a table, a graph, or just given some characteristics. And so this is like the other side of it. So starting with an equation, figuring out the graph, the characteristics, things like that. Here, there's some other connections when I think about the graph, the characteristics, the table, and figuring out stuff about the function and the equation. So there's a whole different set here, very, very similar ideas. But here, we're starting with a graph, starting with a table, and figuring out those features. So a lot of this is going to happen all at the same time. So to set us up, what is the difference between the degree of a polynomial and a leading coefficient? So, terrible example. There. And okay, so what I want you to do, let's just have a whole class discussion about it before we go to small groups. What do y'all think the degree and the leading coefficient would be for this first function? What's 3? The degree or leading coefficient? The degree is what? 3, okay? So the degree, by the way, a lot of times when we say degree, we just use the letter N to represent degree. So if you want to do that, you can. So what do you think the leading coefficient would be? -3? Okay. All right. I'll agree with those. What about the second one down here? Degree 8. Okay, cool. What do you think my leading coefficient is? -5? Some people thinking 2? -5? Why is it -5? Or why do you think it's -5? So Shadidra, why are you thinking it's 2? Leading, right? It's at the beginning, right? So why do we think that it would be 8 here? Or sorry, why do some of us think it's going to be -5 and not that 2? Leading literally means it's leading it. It's at the beginning, front of the line. But the most common response I saw very quickly or heard was -5. Raise your hand if you think it's 2. She's looking around, she's like, I'm all alone. Raise your hand if you think it's -5. We're like scared to say. Okay, I've got like 5 of us, 6 of us. Raise your hand if you have no clue. Okay? Let me remind you of this. This is what form again? Standard form, okay? We're all good, degree, this is the highest power. But this really isn't the traditional standard form. How would I write this traditionally? -5 x to the 8th plus 2x to the 4th. What do I need to do to write it in my traditional standard form? It needs to go from the highest power to the lowest power. What do you think my leading coefficient is now? -5. Okay. So, it is easiest to identify my leading coefficient when it is in that traditional standard form, right? Shadidra, you did exactly what I was hoping somebody would do. We need to recognize that it's not just what's at the front. When we say leading coefficient, what do we really mean? This is the coefficient of what? So, yes, I'm going to add a little bit of language into it. So it's the coefficient of the, what do we call these things that are separated by addition and subtraction? Terms. So it's the coefficient of the term with highest power. Now, if I were you, I might make a note about a couple of these things on that Frere model somewhere, right? Because what we're going to be doing is a lot with this, maybe not in one of those little sections, maybe in the little circle, maybe on the back side, something. But we got to know degree, we got to know leading coefficient. Got to know degree, got to know leading coefficient. So I don't see, sorry, digging into me in a second for what I'm about to do. You're going to want to move over to this area just because I'm going to be working on this board, okay? So get your notes about that leading coefficient. Don't forget what that degree is. Now I will remind you, when we say degree, where do we need to look to see degree? In which form? Standard form, right? So when I'm talking about degree, for the most part, standard form is the easiest to see that highest power. You can find it in factored form, but it is definitely easiest to see it in standard form as the highest power. All right, so we're probably not going to get a chance to get to where y'all are working on these. Yeah, if you want to move so you can see this over here. We're not going to get a chance for y'all to start working on this. I wish I had planned things better, but it is what it is. But I'm going to work on this first one with you. Well, when I say the first one, so each of you are going to have a different equation, right? So remember what cards you have today so that when we go to small groups tomorrow, you know where to go, okay? But I'm going to work through this one with you based on this equation. So this is kind of my starting point. I'm going to consider this equation 1. That's going to be equation 2, 3, and I did it around the room intentionally, and there's a pattern to them because I've said this before a few times. Math is the study of what? Patterns and starts with an R. I haven't said as much this year as in the past. Say again. There are ratios, not the R word I was thinking about. Relationships or relations, right? So it's the study of patterns and relationships. So when I look at this function right here, okay, first things first, you'll notice graph the function using your graphing calculator and sketch it. Literally, if you look over here at the board, that's exactly what I did. Why did it not show up? Oh, I know why. Hold on. Duplicate. Alright, so you can see I just graphed it on the calculator, and I took those features and I graphed it up here, right? So I identified also my y-intercept off there. I used my line of symmetry to figure out some things. But now, based on this graph and that equation, I'm going to start to answer these questions. So for B, what is my degree? Degree 2, okay? That one's nice and easy, very straightforward. And by the way, you'll notice that you have a graph space and the chalkboard or whiteboard space. So how many x-intercepts are there? 2 x-intercepts. And it asks, what are they, I think? So the x-intercepts are negative 4.6 comma 0 and 0.6 comma 0. I think that's what it says over there, roughly, right? Does that sound right?
0.64.
Yeah, I'll just leave it at 0.6 though. How many zeros are there for this function, or how many roots? 2 roots or zeros, okay. All right, now we're on to part D. Part D says how many times does the graph turn? Now I want to point this out. When I say turn, this a term they use here on Mathematic, what I really mean is, where does it turn? It turns at a... Huh? Yeah, there's another term we've learned for this though. Oh, and also that's the line of symmetry, maybe the vertex, right? But what's another word I could use for this turn here? Where it stops decreasing and starts to increase. So extrema, right? When we say turns, we're talking about those extremas. How many times does this function turn? 1 turn, okay? So 1 turn, right? 1 extremum. Specifically, what type of extremum is this one? It's a minimum, right? All right, so what is the leading coefficient of the polynomial positive or negative? Positive. The leading coefficient is 1, so the leading coefficient is positive. F. As your graph goes farther and farther to the left, so as we go left, and so I want to point this out, when we say as it goes to the left, the way we mathematically say this is as x approaches. So as we go to the left, what is x approaching? Negative something, negative infinity. So as x goes to the left, as x goes to negative infinity, we want to know what is y going towards, right? So what direction does the graph go vertically? So as we go to the left, y is going, remember left, y is going up, right? So there's my arrows. So what is y approaching? Positive or negative? Positive, okay? So positive infinity. I'm just going to make a note here, it's going up. That's my left-hand side. Left-hand side. Right-hand side. On the right-hand side, it says, as your graph goes further and further to the right, so as we go right, how am I going to say as it goes to the right? As x approaches positive infinity, right? If I go right for forever, I'm going towards positive infinity. Include that positive in there. Is what's happening to the y? It's approaching positive infinity, so it is going up. Okay? And so, notice I've got those arrows there. So, with g then, do the ends of the graph go vertically in the same direction or in different directions? Are the ends vertically, are they going same or are they going different?
Same.
They're both going up, right? So that is the same. All of these features are going to reveal different parts of the graph that we're going to be looking at tomorrow. And just as a quick, oh, it's already on here. If you look at the top, I should point this out. Please notice on the left-hand side where it says higher power, that's an example of the ends going in the same direction, right? They're both going up. What's it on the right-hand side? On one end it's going up and the other one is going down. So just as a quick reference. And so I'm going to leave all this up for tomorrow, okay? Please make a note on your paper what group you're going to be in, and whether it's kings, aces, queens, whatever. Make a note on your sheet of paper. I'll leave the white books up. We will get started on this first thing tomorrow. If you need to stay during advisory, I'm about to email your advisory teacher right now.